Good afternoon. My name is Jan Corluy. I work with the groundwater management team of Flanders Environment Agency. And I would like to present to you the Flanders Creative Groundwater Level Indicator as an example of groundwater drought monitoring and modeling in Flanders. So, yeah, as we've seen before, Flanders got confronted by droughts in the past 3-4 years. This had a lot of publicity in the press, and a bit to our surprise, even the press started to report monthly on low groundwater levels. Even the results of our indicator, like the maps and graphs, were made into the press, were discussed on social media and even the weather report. Then suddenly, this year, attention shifted from droughts and low water levels to flooding and high water levels, since we experienced the best summer since 1833, the start of the observation in Belgium. Now, drought in Flanders, there are 4 drought levels defined, going from green to red, and the color determines the type of drought measures that are being taken, and that is coordinated by the Flemish Drought Commission. Now, in order, for the function, they can base themselves on a whole bunch of drought indicators which are listed here. And I would like to talk about the drought indicators for phreatic groundwater that we provide. We do that with a tool called the phreatic groundwater level indicator. Generally, it's based on 154 monitoring wells where we have monthly measurements of groundwater, which we complement with daily simulated groundwater levels. So we do a periodical reporting to the Flemish Drought Commission, and also monthly the results are published on the website of the database of the subsoil of Flanders. They are consultable as online map layers and GIS web services, and the results are also included in a monthly report, the status of the water system, which also includes information on weather conditions, soil moisture data, and surface water data like levels and discharges. Now, we provide the indicators to the Drought Commission through an internal drought dashboard. Generally, we provide these maps where we indicate whether groundwater levels, phreatic groundwater levels, are below normal or higher than normal for the time of year. We also include the evolution over the past period, like last year. We make some predictions for the coming months based on different scenarios, high and normal width. And then in this section, you can also zoom in on a different location and get more information there. Now, how does it work? So for every for every location, we run a SWOT model with inputs of daily evapotranspiration and precipitation, and also location-specific information on soil and aquifer characteristics. And that produces, whatever location, daily time series of groundwater levels. The model that we use is the soil, water, atmosphere, and enhanced model by Wageningen University and research. And in the pre-operational phase, all those models are calibrated. So the soil and aquifer characteristics are calibrated. In order to achieve a set of well-calibrated models that can predict groundwater levels based on inputs of weather conditions. So then in the operational phase, there's no more calibration. We get simulated daily groundwater levels, and we complement them with monthly measured groundwater levels via a data assimilation procedure, and we get a corrected or adapted daily indicator. Now, This is an example of a result for one location on a dry sandy soil in the Antwerp province. So what you see here is we have a time axis going from August 2020 to August 22, actually last week, 1st of September. And on the vertical axis we have the groundwater depth below soil surface. So the colored areas that indicate very low, normal, higher than normal, and very high groundwater levels for the time of the year in this location. So we see, for example, on September 1st, the normal groundwater level depth of this location would be around 200 centimeters below soil surface. And we see also that in this location, there's a groundwater level follows a typical seasonal pattern with low groundwater levels at the end of summer, high groundwater levels at the end of winter. Then the measured levels are also here in the black squares, and the simulated levels, the daily simulated levels, are the black line. So what we can conclude from this graph is that last year we had mostly low groundwater levels, lower than normal for a time of year, whereas in August this year they shifted to very high, high or very high levels for the time of the year. Now, if we summarize the relative status on a given day for all of the wells, we can produce this graph. Right? It has the same time axis for last year. Now we can read the amount or the percentage of wells that show very high, normal, low, or very normal groundwater levels for the time of the year. Now, for a time of the year here means that we compare the level at a certain day of the year with all the groundwater levels at that location at the same day of the year for the past 30 years. So we get an idea whether at a certain date we have to dry and wet conditions. And in this graph you can see we come from very dry to very dry conditions in 1st of September 2020. You see a gradual change over the year to come to the actual very wet conditions where only 10% of the monitoring wells show low to very low groundwater levels. So most of them are very high. We can also show the same graph for a different time period. So here the graph starts in January 2000. And here we can clearly distinguish between very wet conditions that occurred in 2000 to 2002, and then very dry conditions we observed in 2017, 18, 19, 20. This is another result where we show the absolute status. Basically it's the same graph as the previous ones, only we don't compare the level on a given day to the same day in the year, but we compare it to all days in the past 30 years. So this graph, we expect the seasonal fluctuation with low conditions at the end of summer, high conditions at the end of winter. And this year was a bit extraordinary in the way that from April onwards we saw slower declines in groundwater levels than we expected. It was due to the small rainfall deficit. And then from mid-June onwards there was even a trend reversal. So we saw suddenly during summer groundwater levels that were rising. It's because we had the wettest summer since 1843. Well, since start of observations. Then we can also present the result as a map. So we have here a relative status and change map for the 1st of September last week. And we see that the colors indicate the relative status for every well for the time of the year. And symbols indicate whether levels are rising, they remain stable, or they were declining with regard to the previous month. We see now that we're in a situation where most of the levels are normal or even very high for the time of the year. If we compare that to the map that we saw in the presentation of Professor Asmus, 3 years ago we were in a complete different situation where almost all the levels were very low and low for the time of the year. We can describe the current situation and past situation, but we can also make predictions. So here you see predictions for the coming month, where we would expect rotations with both absolute and relatively very low groundwater levels for three different scenarios. So you see almost none, and the same predictions we can make for wet conditions. Then, well, as a wrap up, I would like, I can say that the initial purpose of the groundwater level indicator was to raise awareness on groundwater and drought. I think given the huge amounts of press interest and interest of the general public that we saw, we reached that objective. And now the indicator is also used for drought monitoring for the Flemish Drought Commission. And we mostly see it as an illustration of the impact of climate variability on groundwater. This created a lot of questions. Well, all experts have a lot of questions. We tried to tackle this by creating some explainer videos about the groundwater system and low groundwater levels. We included a video on human impact on climate change, and also made a distinction between phreatic and confined groundwater. We also made explain a movie about that. They're available on YouTube. Unfortunately, for the time being, only in Dutch, but I think they're certainly worth checking out. Now, the indicator is still a work in progress. At the moment, we're looking into automatization of our monitoring network. Also, the possibilities of trying different model concepts like time series analysis, machine learning. We want to improve the representativity of our indicator, and last but not least, we want to run climate scenarios to get the first idea, illustrations of the impact of climate change on ground. If you want to explore it for yourself, you can go to this website and you can find the links to the monthly reports, the interactive map, background data, and also an archive of previous reports. And I would like to thank you for your attention, and I also want to point out that this work is there were a lot of contributions of different persons, agencies, consultancies,